Astronomers working with the Atlas Survey Telescope in Rio Hurtado, Chile, made a remarkable discovery on July 1, 2025, when they detected a faint, unusually fast-moving object streaking across the sky. At first glance, it appeared comet-like, but its speed, brightness, and trajectory immediately set it apart from any ordinary visitor to the solar system. This mysterious object, officially designated 3I/Atlas, C/2025 N1, has since been confirmed as only the third interstellar object ever observed, following the groundbreaking sightings of Oumuamua in 2017 and the comet 2I/Borisov in 2019. Its detection has stirred significant scientific excitement, as each interstellar object provides a fleeting but extraordinary opportunity to study material formed around distant stars, carrying with it clues about planetary systems far beyond our own. When astronomers first analyzed 3I/Atlas, they noted that it exhibited outgassing and dust release, behaviors characteristic of comets, suggesting that it is likely composed of frozen volatiles such as water, carbon dioxide, methane, or other ices that begin to evaporate as the object approaches the sun. These qualities make it appear, in many ways, similar to the countless comets that inhabit the outer reaches of the solar system. Yet what makes this object truly extraordinary is not its behavior, but its origin. The 3I in its name indicates its status as the third known interstellar object, while Atlas acknowledges the telescope system responsible for its detection. The fact that it is not gravitationally bound to the Sun is the key to its interstellar identity. Its trajectory follows a hyperbolic path, a shape that no object native to our solar system would naturally maintain unless it were ejected with enormous force. Its incoming speed of more than 200,000 kilometers per hour, or around 61 kilometers per second, firmly indicates that it did not originate within our Sun's gravitational influence. Instead, it must have traveled for countless millions of years through the cold void between stars before wandering into our planetary neighborhood purely by cosmic coincidence. As 3I/Atlas makes its way through the solar system, its path will take it between the orbits of Earth and Mars, allowing astronomers unprecedented chances to track its brightness, structure, composition, and evolution in real time. According to Con Stoitzis, the Comet and Meteor Director at the Astronomical Society of Victoria, the object will cruise through the inner solar system before making a close approach to the Sun and then shooting back into interstellar space. Because of its extraordinary velocity, there is no possibility that it will become captured by solar gravity. After passing by, it will continue outward indefinitely, returning to the vast, unbound darkness between stellar systems. NASA's calculations show that the closest it will come to Earth is roughly 270 million kilometers. This distance eliminates any potential for collision, yet still keeps the object close enough for detailed scientific observation using Earth-based and space-based telescopes. For most astronomers, 3I/Atlas represents a natural and expected type of object, an icy body formed around a distant star and thrown from its home system through gravitational interactions, only to drift for eons before arriving near ours. The behavior observed thus far aligns well with what is known from other comets: predictable brightening as it approaches the Sun, dust tail development, and chemical signatures typical of volatile ices sublimating into gas. However, not all scientists are content with the simplest explanation. One of the most outspoken alternative voices is Professor Avi Loeb, a theoretical astrophysicist at Harvard University, well known for proposing unconventional but thought-provoking ideas about interstellar objects and extraterrestrial technology. Through the Galileo Project, an initiative dedicated to investigating possible signs of non-human technological artifacts, Loeb has raised questions about whether 3I/Atlas could be more than just a comet. His intention, he has emphasized, is not to make unfounded claims, but to encourage open-minded and rigorous scientific inquiry. In a series of essays published on Medium, Loeb explored the possibility that the object might not merely reflect sunlight like typical comets, but could instead emit its own light, which would be highly unusual for a natural object lacking internal energy sources. He questioned whether its observed brightness curve matched expected cometary behavior, suggesting that researchers should consider all plausible hypotheses, including exotic ones. In one essay titled, "Does 3I/Atlas Generate Its Own Light?" he speculated on whether the object could possess technological features, such as radiative surfaces or energy-emitting components. In another piece titled, "Is the Interstellar Object 3I/Atlas Alien Technology?" Loeb went even further, contemplating whether the object could be an artificial probe or relic from an extraterrestrial civilization. While he acknowledged that this idea lies far outside mainstream scientific interpretation, he argued that dismissing the possibility outright would limit humanity's ability to detect potential signs of advanced non-human intelligence. Loeb's essays also touched on the philosophical and potentially existential implications of such a scenario. If, hypothetically, 3I/Atlas were an intelligent probe or even a passive artifact, it would raise questions not only about the intentions behind its presence, but also about humanity's readiness to understand or respond to contact with extraterrestrial technology. He noted that if the object were of artificial origin, its creators might be benign, indifferent, or malevolent, and that the consequences of encountering such a device could vary drastically depending on its purpose. He suggested that, in such an unlikely scenario, humanity might need to consider defensive measures or strategies for communication. These speculations are undoubtedly dramatic and have attracted both public interest and scientific criticism. NASA, for instance, has firmly rejected such ideas. Tom Statler, NASA's lead scientist for solar system small bodies, explained that 3I/Atlas behaves exactly like a comet and exhibits no characteristics that would suggest an artificial or anomalous origin. According to Statler, it looks like a comet. It does comet things. In NASA's assessment, all available evidence strongly supports the conclusion that 3I/Atlas is a natural interstellar comet, much like 2I/Borisov, but with a more unusual orbital trajectory. Following widespread media attention surrounding his statements, Loeb clarified in a later blog post that he was not claiming 3I/Atlas to be alien in origin. Instead, he reiterated that the simplest explanation, consistent with Occam's razor, is that the object is a comet composed of ices and dust. His goal, he explained, was to stimulate scientific curiosity and remind researchers not to fall into the trap of assuming that familiar explanations always apply. Interstellar objects are extremely rare, and each one provides a precious opportunity to gather data about the diversity of materials and processes that exist in other star systems. Whether 3I/Atlas ultimately proves to be entirely ordinary or unexpectedly unique, it remains a messenger from far beyond the sun's gravitational domain, carrying with it the story of a distant birthplace we may never directly observe. The appearance of interstellar visitors like Oumuamua, 2I/Borisov, and now 3I/Atlas marks a new era in astronomy, one in which Earth has begun to detect and study fragments of other worlds that pass fleetingly through our skies. These objects challenge our understanding of how planetary systems form and evolve, offering natural samples from environments that orbit unfamiliar stars. Some may resemble comets from our own solar system, while others may display shapes, compositions, or trajectories that defy predictions. Regardless of their specific features, each one expands the scope of human knowledge and deepens our appreciation for the complexity of the galaxy. For the moment, 3I/Atlas remains under intense observation as it moves on its hyperbolic course through the inner solar system. Scientists across the world are gathering images, spectra, and thermal data to construct the clearest possible picture of its composition and behavior. As it accelerates away from the sun and returns to interstellar space, it will once again become a faint, cold traveler, invisible to our instruments, and left to continue its silent journey through the cosmos. Yet the information collected during its brief visit will be studied for decades, helping astronomers refine their theories and prepare for future interstellar encounters. In the end, whether viewed strictly as a comet or imagined as something more mysterious, 3I/Atlas serves as a reminder that the universe is far larger and more varied than the small corner we inhabit, and that every unexpected discovery opens the door to new questions about our place within the stars.